Alright, so welcome back. Hope you guys having a good Saturday, and we're of course working on this Zelda 3-like game, and we're figuring out how to code a game. So up until this part, this is week 4 now, and up until now we've been working on the movement of our character and the animation. We've also been working on collision stuff, so we can collide with all these objects, and we have a little bit of a fake perspective in here, which makes this look very nice for this art style and this perspective. And the same goes for the tree. We can actually walk behind the tree. We did that last week, and then also we started working on interaction stuff. So whenever we hit space and are close to an object, it tells us it found an interactable sign in this case, and we have an interactable chest here as well. Found interactable chest. It says it in the console. You guys can't see the console right now, but yeah. So this is working. We have, and basically this is where we continue. So what I want to do today is kind of talk about how we can really interact with those objects, because now that we found them, we actually have to do something. So for the sign, we want to have a little text message pop up, and for the chest, we actually want to be able to get something from the chest. And each interactable behaves differently, so we have to figure out a way how we can distinguish between them and have different working interactables. And then we of course also have the sword that we want to grab. This is not an interactable yet, but yeah, if we get to that, we also make the sword an interactable, and yeah, we'll just see how far we get this time. Usually I've been a little bit optimistic with the time when I was planning ahead what I'm able to do in the 2 hours. So yeah, let's focus on the interactables first, the chest and the sign, and we'll see how far it goes. We have some new art for the sign, at least, because if we want to display some text, it has to look pretty as well. I got some fonts, some free fonts from the internet, which in my opinion fit the style of the game quite nicely. And I also got new art from Jesse, and I want to show you. So for the sign, we want to not only show the text, but we also want to show a nice frame around it, which is what Zelda is doing. And we got a nice frame here from Jesse again, so we can use that to display the text in a very nice way. We'll see. And in turn we can talk a little bit how to do UI stuff in Unity. Since we're in Unity 5 now, there's a completely new UI system. It actually got introduced in Unity 4.6. So we're going to figure out, learn a little bit about the UI system and how that works, and yeah, how we can display stuff like text from a sign on screen and stuff like that, which should be enough work for a 2-hour live stream, I guess. But we already are pretty have a good standing from last week, because we figured out a way how we can find the interactables. So we already have found them, and now we have to make them do something once we are interacting with them. So we did it such a way that we have to face the interactable in order to interact with it, and also the object has to be pretty close to you. At least, I mean, yeah, that's one thing that we still wanted to do. So right now, what we do to find the interactables is we put a sphere around the character, and we get all the physics objects that are within the sphere, and as soon and then we go through all the objects that we got from this, and see if there's an interactable with it. And we find out if there's an interactable because the objects have a component called interactable on them. So this is quite easy. So you could use tags as well, you could use layers, there are different ways, but I chose to make a component out of it because then we can call this component, say, hey, we want to interact with you, and the component itself can then do stuff with the, and yeah, do whatever needs to be done. And yeah, but as you can see, maybe see if I can interact with the chest from here, which is pretty far away. I actually wanted to have it in a way that we are pretty close to the chest to interact with it. So let's rein that in a little bit. I think now we are creating a sphere with a size of 10, not 10, of 1, and we just make it a little bit smaller to be able to only get the objects that are very close to us. All right, so let's see once we hit space. This is something that we did in the keyboard control here. Once we hit space, then we calling this on action pressed, and the on action pressed calls our interaction model, if we have one, but our main character has one. And it calls the onInteract method of the interaction model. So it's there, and then in onInteract we find the usable interactable, and if we found one, then we call it out basically. And this is where we want to continue our work. But the way that we found the interactable is here. We call the overlap circle, that's what I said, and we have a radius of 1. So let's just we could make a parameter of it, so we could make it much easier, edit it much easier from the Unity editor. But I think it's not necessary in this case. We just use the 0.8. I think that should be enough. Let's test it quickly if we can still interact with the chest, and if that works, then it should be fine. So, I don't want to have it big so that we can see the console still. So can't interact here. We can interact. Yeah, I think that's all right. So we don't have to be that close. I think this is good. One thing that I saw when I went through the code that we did last time is that we are casting this circle from the transform position, which is the position of the character. So as you can see here, the position of the character, you can see it in the scene view, is here where these two arrows meet, and then we cast a sphere around that, which actually works out kind of. But you see, this is not the center of our collider, which is a little bit below that, and also the collider is a different size. So if we cast a circle around it, actually there are multiple different. It will be different from if we interact with the object from the side or from the top or bottom, which is. But we want to have it consistent. So. So we want to have a consistent distance to the objects to interact with them. So in order to do that, we're actually going to change our physics code a little bit, because there's a different method that you can also call. There are different overlap methods, and right now we're using overlap circle, but we can also use overlap area, which allows us to create a box, and we can make that box in such a way that is it is a little bit bigger than this box. But the thing is, this is not very interesting to do on stream, and we're not going to learn something new from it. So I'm going to do that afterwards, before I upload the code to our GitHub, or I do it next week, or basically before the next stream, so we don't have to waste time now, because the method works that we have right now. It's just some fine tuning that we don't have to do on stream here. So I just wanted to bring it up so that you guys know that this is something we can do as well. So right now just to show it in the code. Right now we use the overlap circle all, and it takes a position, basically where the center of the circle, and then a radius. And we could also use the let's go over here. We have the overlap area all, and the area is basically a box, a rectangle, and it looks for two vectors basically. So the top left point and the bottom right point, and then basically that is our overlap area. But okay, we're sticking with the circle for now, but I'm going to change that once I'm done with the stream. All right. So question is, can't you just minus y from the circle overlap position? Yeah, but then sure, but this is it will be. Yeah, it's not very clean. It's just, and then you have all these different conditionals and stuff. It's just way easier to just use a box, because this way we can make the box a little bit bigger than our actual box, and then everything will be exactly as we want it. Your way would work as well, but it's kind of rough. Works kind of, but we want to have it very consistent and clean. So. Okay, so now that we found our interactable, we actually want to do stuff with it. And the cool part about using the interactable component is that we can now go to the interactable component and create a method on it, call it void onInteract as well. And basically we call this method. But the thing is, we want to have different stuff happening depending on which object you interact with. So there's different stuff happening if you interact with the sign than if you interact with the chest. So, but right now we only have this interactable component, and a very easy method to do that is that we use class inheritance. We can. Well, we can do multiple stuff. We can either do class inheritance or we can class composition. Those are two different methods for doing that. So let me go over them very quickly. So class inheritance is basically what we are always doing with this mono behavior here. So every component that we create in Unity, let me make this slightly bit bigger, is actually a mono behavior. And mono behavior is a class that Unity wrote for us basically, and has some basic methods here, basically telling Unity this is a component that you can put on a game object. And we can do the same as well. We can create a new class and say this is not a mono behavior, but this is an interactable. And then the new class is an interactable as well, but we can override some methods in there so they do different stuff. So basically we could have a sign interactable, and we can have a chest interactable, and whenever their onInteract method is called, the sign puts up the text and the chest opens up and gives us an item, which is exactly what we want to do. And this is the method that I'm going to use. The cool part is, because I explain the cool part later when I get to that in the code. It's much easier. I just want to quickly say what class composition is. So we could also create an interactable, for example, a sign interactable, and then we could do something like broadcast message on here. And broadcast message is basically you can use it in any component, and then you put then you can put a string, a method name in here. So let's say onInteracted with by character. I want to call it a little differently than this one. And basically what happens now is Unity goes through all the components that are on the same game object as where we're calling this, and calls this onInteracted by character. And it doesn't matter which component you put on there, as long as they have these onInteracted by character method, this method will get called. And so those are two different methods that we can use. But what I don't like about this is that we have a string method in here. So when we want to rename that method, we can't really refactor it because this is a string and not a reference to the actual method. So we have to remember that we have this broadcast message, and that we have to rename it there too and stuff like that. So it could work if you. The cool part about this is that you don't have to have something that has this function. So it can call as many as you want. It can also call no component at all. So there are different situations where each way is appropriate, but I want to use the class inheritance method. And so whenever I do that, I basically have a naming scheme that I do. It's not required, but it's just for me so that so I know quickly what's going on. So we have the interactable here, and then I call this interactable base, because this is the base class basically, and then each new interactable will be called the same name, interactable chest, for example. So now that I created this interactable chest method class, I have to, first of all, I have to also rename the class itself, because we rename the class the file name, and it's always good to have the file name and the class name the same, so you don't get confused. So so we have interactable base here, and then what we can do in interactable chest is interactable, yeah, I spelled that correctly. So instead of having this extend mono behavior, we're having this extend the interactable base. And basically the interactable chest is an interactable base class now. It just has additional functionality. The cool part about this is that interactable chest is considered an interactable base. So when we do I should have refactored that and not just renamed it, but it's fine. This is basically what I wanted to show you. So we can still do a get component for interactable base, and if you have the interactable chest component available on a game object, this get component interactable base will still return the chest class, because the chest class is an interactable base class as well. And this is why this would work, because we are just basically we have all these different interactable classes later for every conceivable type that we need, and we can basically just do a get component for interactable base, and then we get that class back, whatever that is. We don't have to know now which interactables we will have later and stuff like that. We just know that we want to get an interactable base and interact with it. And one additional thing, so now what we need to know is we need to have an ability to have different functionality depending on which class we're using. So the interactable chest will have different functionality than the sign. And what we can do for that is we define a virtual method. So we make on interact a virtual method. So it's it's virtual here. I can't actually. I don't know right now if it's here or here. Does it even make a difference? I don't know. I always put it. Where do I always put it? I actually forgot. Brain fart. Public virtual void. Virtual. I think I put it in the front. Let's put it in the front now, because now that we know it's virtual. But I'm actually not quite sure if that's the correct way, correct order of the keywords here. But the compiler would tell us if we did a mistake. So what we need to do now is we need to say that this class is virtual as well. No, I think no, we don't have to. What am I saying today? So anyway, so we do this virtual, and whenever we have a virtual method, this basically means we can change that method. So we can also implement the onInteract here, but we say we change the virtual statement to an override statement. And override basically means don't consider anything that is written in the base class. Use my implementation instead. And this way, each different class, the sign and the chess class and the sword class and whatever, they can all override the onInteract method. And but the interaction model doesn't have to know that, because here we're basically interacting with the base class. So we're calling onInteract, and we only know this is an interactable base class here and whatever. But since the chest overrides this method, basically the interact method from the chest is being called and not from the base class. I hope that makes sense. But the cool part is about this is that we don't have to know right now what all the methods are, because we can use the same method name, and whenever we have a new interactable, we just override it again, do new functionality, and it just works. So, and if you create an interactable and don't override the method, then basically the base method will be called, so nothing here. So we can basically, for ourselves, we can put a debug warning in here and saying onInteract is not implemented, so that when we create a new interactable and we forget to implement this class, whenever we interact with that object, something still happens, and the console basically tells us, oh, we have to implement the onInteract method. And then for the chest, so let me show you exactly log. We're basically saying here interact with sign, and then we do the same. We create a new class for the this is the chest. We create a new class for the chest, and interactable chest. We have chest already. We create another class for the sign. My computer is so slow when I'm streaming. It's like capturing a 180 region of your screen is hard to do or something. I don't know. Anyway, so we just have to be patient a little bit sometimes. So we want to do the same thing for the sign. So right here we have interact with sign, which is in our chest class, which is wrong. So we have interact with chest here, and in the new sign class that we just created, we also have override this method, but we override it with something differently. We're saying interact with sign. And so now we have two different interactables basically. Oh, and the interactable sign also has to inherit from the base class, so that the sign is an interactable base class. And now we can use those two classes instead of just having one interactable component. We're basically putting the component that we need on there. So let's see. Let's go to our chest here, and instead of having the interactable base here that we had before, we actually want to have the chest component in here. And I remove the base component again. So I have the interactable chest now. And for the sign, I do the same thing. I remove the old base component that we had on there and put the sign component on here. And then in the interaction model, yeah, I already called onInteract. So now you're going to see what this virtual override stuff is actually doing. So just a quick reminder, we're getting an interactable base here, we're looking for that, and we're calling the onInteract method on that. Press play. So how will you make the chest give you stuff? Well, we're getting to that. Be patient. I think we're going to do that today as well. So I want to show you guys the console as well. So let's go to the chest and we hit space, and then it says interact with chest, which is basically the onInteract method of the chest class. And if we walk over to the sign, it says interact with sign. So this is exactly what we want to do, because now we have we can just create as many interact classes as we need, and every interact class can do something differently. So in order to let's start easy. Let's go for the chest first and don't have anything in there, just open it up. We have a different with my project stuff, and we go to the chest. We have a different sprite that looks like an open chest. So we have the closed chest here, and we have an open chest as well. So for the beginning, let's just switch the sprite so the chest looks like it's open now. In order to do that, we are going to go to the chest class, and first of all, we need a reference to the sprite, to the open sprite, so that we can then change the sprite in the renderer. So we get a public sprite, open chest sprite, and what we can do here now, but just quick reminder, we set this object up in a way so that we have the chest as a parent, and then we have the visuals as a child object to that. So basically what we want to do is, when we interact with the chest, is we want to get the visuals object, and we can do that because this is a child, we can basically do that with the transform. In transform you have a method called getChild, for example, and getChild just takes an index. So basically, if you have 5 child objects, the first one is index 0, and then index 1 and stuff like that. And you can do that, but and for now we only have this one object in there. But if we have more objects later, it's going to potentially have a problem there. So you can also do find. So you can put visuals in here, so you actually find the object by name, the visuals object. But the coolest is actually we can just do get component in children, and then it looks for through all the children and gets the component for us. And since we want to have the sprite renderer, this works out well for us, because then it gets this, the parent object does not have a sprite renderer, as you can see here. Only the visuals object has one, and so we're going to get this component here. And then we can change the sprite of this. It has a sprite parameter, and then we can set this to a open chest sprite. And that's basically everything we need to do. So no, we need to do one more thing, and that is we need to set up the reference to the open chest sprite. So we have a public variable here, and if we define a variable public, we get a value in the inspector, so we can set it. And so I simply drag the open sprite in here, and now this is set up. So when I press play and move over to the chests, and we can interact with the chest, and now the chest is open. And that's how a chest works, basically. I mean, of course, we're going to do more stuff with it, but yeah, so now we interacted with it, which is kind of cool. We open the chest, and I mean, I can interact with it again and again, but we always set it to the open sprite, so it doesn't appear, it doesn't look like anything is happening. But later on, if there's something in the chest that we are being given, we want to make sure to check first if the chest is already opened, so that if there's money in there, for example, if there are rupees in here, we cannot just go up to the chest and just get an unlimited number of rupees basically over and over again. So we need to check if our chest is already open or not. And we do that with a simple boolean. Bool. I mean, we could just check if the sprite is the open chest sprite, but Yeah, but I don't like that. It's not communicating correctly what we want to do. I want to have a boolean here is open, and basically it's open is set to false in the beginning, and then we set it to true once we interact with it. And then we do a check in here if is open. So if the chest is already open, then we just want to return and not do anything. Cool. And then for the... So we need to figure out first... So I want to do the interactables first. So let's leave the chest at that for a second, because I don't want to get into how we get items yet. Because we need to create a kind of inventory stuff for that, and we do that in a second, because we also have the sword. So I want to have the inventory a little bit more complex, so that we can put more items in there later as well and stuff like that. So let's leave the chest at this for now, and let's go over to the sign first. So the sign needs to basically create, basically show text. And in order to do that, we need to set up the dialogue a little bit. So in the new Unity version, Unity 5, we can create UI elements by using canvas. So we have lots of different UI stuff, can create lots of different UI stuff like buttons and sliders and stuff like that. And this is basically everything. If you go to game object and then UI, you have all these different UI components that you can use. But for now, we just simply need a panel, and we need some text on there. So let's create the panel first. And you can see here something has happened. The screen got a little whiter, and this is actually because this UI stuff is pretty huge right now. And it's right now the UI is set up so that each pixel is basically one unit in Unity, and that's why this is so huge. But for our game, this is actually not a very good way to represent this, because as you can see here, yeah, we can't really work with it. We would always have to zoom on if we want to use the UI, and zoom back in if we want to work on the game again. So this is going to be a workflow issue, but we can change this actually. So once we created the panel, you can see here actually multiple objects were created. So we have a canvas object, and the panel is inside there, and we have an event system. And the event system basically, as you can see here, it has touch input module, it has a standard input model, stuff like that. So what the event system basically does is listen for input, like keyboard input and touch input and mouse input, and sends it to the UI stuff. So we don't have to care about that. Unity set that up for us. But in the canvas itself, basically a canvas means this is the setting up the UI area basically, and everything that you want to draw. If you want to draw UI stuff with the new Unity UI system, you need a canvas-based object, and we can set up. You can see here in the canvas-based object we have different options that we can choose from, and the options that we are interested in right now is the render mode of the canvas. Because you can see right now this is set up to screen space and overlay, and screen space basically means one unit is one pixel. But what we want to do is we want to have it to screen space as well, but we want to have it as a screen space camera, because now we get new options actually, and one important is the render camera, because we can set up the camera now, the one that we're going to use. And where is our camera actually? Oh, it was in the, yeah, it's here. So we can set the main camera in here, set it up, and then you can see that the UI is now as big as the camera in the scene view now, which is much better to work with for our purposes. If you're making a game that, or if you're making a scene that just has UI, the overlay mode is actually easier to work on, because then the canvas is not scaled. You can see here that Unity scaled this canvas now and stuff like that. So you have all these scaling is always, it's not an issue, but if you can get away with not scaling anything, it's always better than, because scaling can create issues if you have huge hierarchies of objects and stuff like that. Okay, but you can also see that the UI is drawn behind everything, and this is because something that we talked about earlier, the sorting layers. You can see here this canvas also has a sorting layer option, and it's right now set to our default sorting layer. And our default sorting layer, let's go back to the added layers screen here. You can see here the default sorting layer is actually the one that is the furthest back. So the easiest thing to fix this is actually we just create a new layer and call it the UI layer, and always make sure that the UI layer is the topmost layer. I think this is the easiest. And then we go over to the canvas and set our sorting layer to UI, and then you see everything is drawn on top of our game. Okay, and so let's work with the panel. You can see here the panel actually has a default graphic in there. It's basically a white transparent background with rounded edges, but we want to have our own panel in here. So let's put our sprite in there. I have set it up, I saved it in sprites, interface, and dialog frame. Let's put that in here. Okay, this is good. It's a little bit transparent. This is because the color has transparency in here, so we want to have full transparency. But you can see that actually this is stretched in a way that we don't like really, and because it now fills the screen, but this is the size that we chose for the panel right now. We resize it later, but basically let's resize it a little bit just to have it 0.8 here, and we put 0.2 over here, so you can see we can resize stuff, and this is basically the new rect transform that every UI element has. You can have absolute values in here, so how much pixel from, let's put this back actually, so how much pixel from the left screen, and how much distance to the right screen, stuff like that. You can set it up in a different way so that it's anchored, and that you can set the width and height of it. So tons of different stuff. I don't want to go into all of that. The first thing that I'm concerned with is you can see here that actually the corners get squashed and scaled, and that doesn't look very nice. What we want to have is that the corners are always looking nice, and then the stuff in between is the stuff that gets scaled. And we can do that in Unity pretty easily actually, which is very nice. So what we can do is we go to our dialog frame here, we select it in the project so that we get the import settings, and we go to the sprite editor. It has a little bit of a border. I need to clean that up later, but I'll do that after the stream, that's fine. So what you can do in the sprite editor, you can set a border for a sprite, and this is basically just a pixel value, and you can see it visually here as well. You can also drag this, and so we have the border here, we have the border here, and we want to have a top and bottom border as well. And basically what we're doing right now is we're separating this object into 9 different parts. So we have the corner parts here, and then we have those parts. And if we save that, we can tell Unity that that we want to use the corner parts so that the corner parts always are scaled, are not scaled at all, and that only the center parts are being scaled. So This is actually pretty cool stuff. So let me clean this up a little bit. Let's just make it to 128 on each side. I think this is good enough. And then right now nothing has happened yet. We still have to set up something. So if we go back to the panel is basically just an object with an image, UI image attached to it. And you can see the image type here. It's set to simple right now. And what we want to do is set it to sliced. And look at that. That looks much, much better. And slice basically means leave the corners as they are and just basically just stretch the center parts of it. So no matter how we stretch this, basically, it always looks pretty nice, except if we go smaller than what the corner. If we go smaller than the size of the corner parts, it gets stretched again. But since the UI goes over all the screen anyway, this is no problem for us. But yeah, this looks very like a very good UI screen, dialog screen. And then just put some text in there, and then and that's our sign basically. Thank you. That's what I needed. Yeah, you're welcome. I mean, the new Unity UI system is new, so we all have to learn stuff about it. What I kind of don't like is it's still a little big. So if I maximize it, you can see here that oh, it gets scaled. Oh, I haven't scaled the, yeah, okay. One more thing. So you can see here that I set the width and the height of the UI element here to, it's now at, let's put it some even values in here. So it's 600 by 400. And if the screen grows bigger, it actually still is at 600 by 400. Which is not what I want to do. If you have a bigger screen, I basically want to scale the UI up as well. And normally in games, I mean, you see that in all games actually, if you have a bigger resolution, oftentimes the UI gets smaller. If you have a very big screen, then it's often very hard to read something, or if you put it on a beamer. So that's not what we want to do basically. I want to set it up in a way that it's always scaled. So if I have a bigger area, the UI gets scaled with it. And we can do that pretty easily on the canvas actually, with something called the canvas scaler. The canvas scaler was created for us once as the canvas was created. So we have the canvas component up here, and we also have the canvas scaler. And right now it's basically set to constant pixel size. So if we say the dialog is 600 pixels, it will be 600 pixels no matter how big your screen is, what your screen resolution is. It's always 600 pixels. But we also have scale with screen size and constant physical size. So constant physical size is good if you're, for example, working on UI stuff on different with different screens. Like if you work on mobile, for example, the new iPhones with the Retina display, they have a much higher pixel density, and constant physical size basically takes that into account. But we want to have the UI scale with the screen size. So if the screen gets bigger, the UI gets bigger as well. And then we have we can basically set up a reference resolution. This is just so now it's set up to 800 by 600, meaning 600 pixel in height is 100%. So if we set this height to 600 pixel, it's basically it fills the whole thing. And you can screen match mode, so you can say how it should expand, shrink, and stuff like that, and you have some values that you can adjust here. And what I want to always what I do is you can match width or height. So basically it scales either the width to the full to your screen, and then scales the height accordingly, so to keep the same aspect ratio. But we can also slide this value over, so the same thing happens with the height. Basically, what you're setting up with the slider is: should I scale to the width of the screen, or should I scale to the height? And I always use the height because if you're having different aspect ratios, like we have 16:9 here, and we actually but we could also have 4:3, and because we are scaling by height now, the it stays the same, basically. If we set this to width, let's set this back to width again, and if we change the aspect ratio now, you can see that it's actually scaling it. And yeah, because the aspect ratio basically changes the width, I always set my UI up in a way that it's relative to the height. So this way aspect ratios don't matter. Which is good, but the thing that we have to take in mind now is that if we make it too big, actually, and we design it in our 16:9 stuff, you can have it cut off, basically. So we have to keep that in mind. But that's fine. I always design my UI so it works at 4:3 screen stuff, and then either there's some fluff that you don't need on the side that gets revealed once you have a wider screen, so it's not empty, or I just don't have anything. So we're just going to make sure that it'll fit into the 4:3 area. Make it a little bit smaller, and I'll also want to have it down here. And yeah, so this is how dialog works in Zelda. It always has this rectangular box at the bottom part of the screen. And since we designed this in 4:3 now and made sure it's visible in 4:3, it will work perfectly in 16:9 as well. And yeah, so now we want to put some text in here. So let's rename this. So this is our sign dialog box. And basically what we're going to do is we set this up in a way that every script can access this dialog box and pop it up. And it will always be the same. So if somebody is speaking, he will use this dialog box. If we read a sign, the sign will use this dialog box as well, so that we don't have to set this up over and over again. We only have one dialog box and it would always look the same. Where are you from? I'm from Germany, and I'm in Germany right now as well. Okay, so we want to have some text in here. What we do is we create a new UI element called text. And you can see, and we make it as a child of the dialog box, just that we know it belongs together. And you can see here a new text was created. It's pretty small right now, but yeah. Let's move this first. So we want to make sure that it's stretching. So this is all the new UI stuff. It was anchored before, and if it's anchored to the center, you can set the width and the height and the position stuff, which is how you would expect it. But you can also make it stretch. So it basically you can set the percentages, and I want to make it stretch to the. It's always relative to the parent. So in this case, if we make it stretch, it would stretch to the boundaries of the dialog box. And then say so the border to the left is 0, border to the right is 0, to the top is 0, to the bottom is 0, and now it's basically 100% of the dialog box. But then again, we still we don't want to have it in the top left here. So let's figure out what the distance to the left is, and I think here would be good, like 80. I think 80 is a good value, and then from the top as well. Does 80 work as well? Yes, 80 works. So let's use just use 80. And basically what we did now is we said this text box should scale with the parent, but always have a border of 80 pixel. So when we change the size of the dialog box, the text actually moves with it. Because, yeah, it's because we set it so it would stretch. And this is some of the cool stuff you can do with the new UI system. It's really important that you just experiment with the rect transform a little bit, because it's at the beginning it takes a little while to get a hang of it, but it's a very powerful component, and you can set your UI up where you can anchor it to the right, to different corners of the screen or stuff like that. So you can do a lot of stuff with it, but yeah, you have to get used to it a little bit. And there are really good tutorials on how to use the rect transform stuff from Unity themselves, actually. So if you go to the Unity YouTube channel, if you go to the YouTube channel of Unity, you can see they explain it very well, actually, so I won't repeat all the stuff here. There's a question: tile-based or just like most of the tutorials? What do you mean tile-based? The terrain or the objects, or what do you mean? Because right now everything basically is a different object, but later I want to make the terrain tile-based. Yes, but we didn't get to that part yet. So the terrain will be tile-based, and all the objects on top will be separate objects. Okay, the UI stuff. The text has to be a little bit bigger, of course. It looks a little wimpy right now. So we have in our text game object, we have a text component, and it has all kinds of different options. So, and the font size is basically what we want, and we want to have a different color. If you scroll down, you can see it here. Let's change it to white. And then, okay, there's a follow-up question. So, oh, you're not using a 2D array for a map. Then how are the collisions being handled? So the collisions we actually did 2 weeks ago. Unity has a built-in physics engine, and so our trees, for example, are using colliders, and you can see here let me use the singular tree, it's easier. You can see the green lines here. This is basically the collider, and our character has a collider as well. A box here, and then basically the physics engine uses those colliders to figure out what stuff is colliding. So this is why we cannot walk through the tree or through the stuff here. And yeah, so basically we're using the built-in physics engine from Unity. We were working on the text here, and I also, like I said earlier, I also found a cool font that we can use, and that works with our setting here. I actually have two, one for headlines and one for text, and then we can set this up in the options here, in the text options. We just drag our font over here, and then we have a kind of medieval looking text here. And I think this works. Let us see if I go longer here. And we can set up all different stuff for the text. So right now, this actually works pretty well, I think. The font size is pretty good because we have 3 lines of dialogue in here, and if we have 3, the distance to the top and bottom frame actually looks very similar, which is nice. And yeah, we can also set the text up so it's vertical aligned to the middle. This way, if we have fewer lines, they basically are stuck to the center here, which is also nicer than having it at the top, because this looks a little awkward if there's basically just one line at the top. So yeah, so that's the text in the new UI. You have tons of different stuff that you can set up here, how it should handle it if you have too much text, and so the overflow basically for vertical and horizontal. color stuff. You can even assign materials, so it's not just a single color. And yeah, line spacing, so tons of stuff that you can set up, but actually I'm pretty happy with this, with how this looks. So we're going to keep it that way. Okay, so dialog text. So once we press play, you saw before that basically the dialog is showing all the time, and this is not what we want. We want to have it that we can trigger it and make it disappear again. So let's create a new script for that. We need a script for our dialog box. Put a new folder here, interface. Call it dialog box. All right, let's go over here. And how the collisions are being handled with 2D raycast. What do you mean? Because with just normal movement it gets a weird feeling. What do you mean actually? We're using the physics engine to move the character, so we're setting the velocity, and this is so we're using the velocity of our character to move him around. Velocity is a property of the rigid body, and we're just setting it. Let me quickly go over here to show you what I mean. In the movement model, we are basically in update movement. We are basically setting the velocity to the direction that we want to move in, and body is basically our rigid body here. Okay, let's go to your collisions look so smooth. Well, for now, since we're setting the velocity, basically the physics engine can make sure it's saying that, well, even though your velocity moves to the right now, there's an obstacle here, so we're so Unity then says, well, even though you have a velocity, you cannot go further here because it's colliding with something else. And I think this looks actually very nice. It works pretty well. I mean, you could also say, you can also create an effect, so once you collide with something, you can have a little bit of a bounce effect, so you get to go back and stuff like that. But yeah, so, I like this. I like this very much. And okay, let's get back to the dialog text then. So, in our dialog box, we first want to have a reference to our text component, because this way we can change it later. And also we want to be able to show the dialog box with the text, and we want to be able to hide it. So let's start with the show part. Public void show. And then also we want to have a string in here to know what text we want to show. And so whenever we show the text box, we actually, the easiest thing that we can do is we can simply hide, disable the image, which means it's not being rendered, and we can do the same with the text, and then it disappears. So in order to show the dialog box, we can simply enable the two components at the same time, or disable them if we want to hide it. So the dialog box component, let us put it here, dialog box. So it's on the same game object like the UI image is. So we can we do a get component, and we can't actually just say image, because image is a component, it's a Unity component that lives in a different namespace. All the UI stuff is in is in Unity engine.ui. So they grouped it together, and then we have image here. But we don't always want to type all the long stuff here, so we can put this Unity engine.ui, we can put it up here in the using statements, and now we can simply use the image component. This is something you have to keep in mind when you work with when you work with UI, you have to use the correct namespace here. So when we show, and then we can basically just say there's on each component there's an enable property, and this is basically the checkbox here if it's enabled or not. So when we call the show method, we want to enable this, and we also want to enable the text. So we do the same thing as we did before, get component in children, and then we have text here, and text is also UI stuff, so it's in the UI namespace here, and we want to enable that as well. But since we're using we also need set the text. We want to change the text that is shown. Let us save a reference of this, so we can use it again. So text enabled is true, and text, the UI text has a property called text. There's a lot of text here. Let's rename that so it's clearer. Component. We have text component, and let's call this display text. And then we're setting the text property to the display text here. So if we start off and we disable those in editor, start off with those being disabled, and then on start let's just show it immediately on start with the text hello world. So yeah, I disabled it now. You see both components are disabled, but in the start method of our dialog box they will get enabled immediately and show the text if everything went to plan. And there you go, the text is shown immediately. Hello world. Alright, so now we need to access that from somewhere else. And there again are different methods to do that. Something that I often do, and it's controversial. People actually don't. Some people don't like that a lot, but I find this to be very. It just works. It makes the code very easy. I use static variables to access stuff like this. So, for example, the dialog box. I need to be able to access that from anywhere in the code and be able to say change the dialog box to the text I want to display. And what I can do is I can create a public static variable of the type dialog box, and I call this instance. And in my awake function, remember the awake function is called earlier than the start functions, so I always set up references in awake and start working with them in the start function. I set the instance to this. So basically, exactly, it's basically a singleton. So once this gets created, it stores an instance of this component in this variable instance. And since this variable was declared a public static variable, I can access this from wherever, from anywhere in the code by just typing dialog box dot instance, and then I can do show. And some people don't like that a lot, but I find for objects like this dialog box that I need to access from anywhere, I favor code readability over what people call good style. I mean, it's personal preference, but I highly value code readability in my code. So, and I find that if I put this anywhere in my code, it's really, really readable and very easy to understand. So that's why I do it. Screw the haters of static variables. So basically what we can do now is, I don't want to do this in the start functions. We don't need anything for update. And we can go to our interactable sign, and on interact we can basically say show hello world. Well, let's link it. It's dangerous to go alone. And you can see here basically it's very readable. Even somebody who is not able to read code sees it looks kind of like plain English. Even, well, the instance path is kind of weird, but we can also fix this by making this this show function static to make it even more readable. So this way we can access the show from anywhere. But the thing is, we cannot use getComponent in static functions, because static basically means I don't have a game object from this. This works without an object, and the getComponent only works with an object. But what we can do is we can use other static stuff. So what we can have a doShow method here. Let me set this up first and then I explain it. Display text and put the stuff in here, and I can access the instance from here and call doShow on the instance, which is the object basically. So the static show method can now be accessed like this. So we don't have to have the instance in there. And what we can do is we also don't have to have the instance public, because basically just the dialog box itself is accessing this. So we don't have to have this public. We can still access it from the dialog box itself. And we also don't have the doShow method public. It's a private method, but since we're calling it from a dialog box itself, we are allowed to call it. So this works exactly as you would expect, but we can basically type dialogbox.show in wherever we are in the code and just show it and show the text that we want. And I think this is, yeah, you can't get more readable than this, I guess. Hello Donald Duct Tape. Nice name. So let's see if that works. Let's go to the sign, interact with it, and see if the text box is showing up. Press play here. Move over to the sign, interact with it, and there you go. It's dangerous to go alone. So now that we have shown the text box, we also need to hide the text box again. And I think, I cannot quite remember, in Zelda you can basically have to press A again. I don't know. Yeah, we can decide how we want. Basically, what we can do is we could just hide the text box from here. But first of all, we need a hide method, and we do the same thing. Public static void hide again, and then create a void doHide method that basically reverses what we did before. So we need this and we need this, and set enable to false in order to hide it again. Enable to false, enable to false, and then call instance doHide here. Good. Did you make the sprites? No, I didn't. Yes, Jessica did the art. Exactly. Jessica's a friend of mine, and she created all the graphics. Okay, so now we have to figure out. So I want the player to press space again, and then the text box is hidden. Basically, what we can do here is, we can use the singleton function, and we can use the singleton function to press space again, and then the text box is hidden. Basically, what we can do here is, we can do here is, we can use the singleton function, and we can use the singleton function to press space again, and then the text box is hidden. Basically, what we can do here is if the character interacts with the sign again, it gets hidden, and then we remove the ability for the character to walk when we are reading something. So this way he has to press space again, interact with the sign again to hide the text, and then he can walk again. So isn't it easier to store image and text than get the component every time you want? You mean here, instead of calling get component every time? Yeah, I mean, you could store it in variables, and yeah, I think that's, yeah, I think you're right. We don't have to call get component every time. You're right, I also don't like that a lot if I have get component in my code. So let's fix this. We can have a reference to the image here, dialog frame, and then also a reference to the text. Text. And we set this in the don't worry about the typos. And then in the awake function, remember the awake function is for setting up references. So we put this code in the awake function, get component here, and store them in the variables. Store that in the variable, and remove everything behind it. And then we can use those variables every time. Dialog frame, and the text. And so we don't need this as well. Yeah, it's much cleaner this way. You're right. Good. So first of all, so in order for that to work, so that we can hide it again, we need to know if the dialog is shown or not. And what we can do in the dialog box here is we can basically have since a static is visible, and then we basically see if the dialog frame is enabled or not. As so we can go to instance and dialog frame, and usually you cannot access the private components, but since we're in the same class, we can actually do that. So we can basically just see if the dialog frame is enabled or not, and this is our is visible. So what we can do now is basically we check if dialog box is visible. If it's true, so if it's visible, then we want to hide it. And if it's not visible, then we want to show our text. And I would store the text in the interactable sign as a variable. You can change it quite easily in the editor then. Yeah, you're correct. Let's do that. So we can reuse it over and over again. So basically we put a public string here. Let's call it sign text. Oh, we could just call it text. We're in the component sign, so that will be redundant. And then just basically have this variable here. And then in the editor we can click on our sign once it's compiled, and we can set the text here. So we can use this component over and over again. Good. So now we can show and hide it. But there's one more thing we need to do, but let's check this if it worked. So we can go to the sign, press space, hi Lang, how are you doing? We space again, it's hidden again, but we can still walk when it's visible. And then since we basically use the interact to hide it again, we can go away, and then we cannot remove the cannot make it invisible again. So that's why I want the character to be frozen in place basically. And we can, when the dialog is visible here. So we need to need to change our character a little bit. So let's see. We want the character to be frozen in place, basically. So we have our character, not movement view. We have our movement model, and basically what we want to be able to freeze the character in place, basically. So let's, for now, just make a variable here in our movement model is frozen. It's default. And then in our update movement method here, basically we check if the character is frozen, and if that is the case, we set the velocity to 0. Vector to 0, and we return so that we don't call the rest of our code here. And then we also need a way to set this to frozen, so we make a public void set frozen, and then we set this variable. So we can basically call set frozen to true or set frozen false in order to freeze the character. But in order to do that, we need to know in the sign. Basically, here we would set the character to frozen here when we show the dialog, and we can unfreeze him again when we hide the dialog. But we don't have access to the character here. And what I want to do is, so we could do what we did for the dialog box. We could create an instance to the character, but maybe we want to use the characters in different places and reuse the character later again. So actually, I think the best method would be that we pass on a parameter to the onInteract with the character that interacted with this interactable. This way, our AI can interact with stuff like it too, if we want to do that later. Let's see here first. There are a couple of questions. Won't we have a problem if the text is too long? Is there an easy way to check this in Unity? Well, if the text is too long, we saw before what happens in a text box. It will get clipped, yes. There is a way to check that, but I don't worry about that now because the text will never be dynamic. So we can test if it's too long. Basically, when we play, we'll see if it's too long. I mean, sure, we can. Later on, you have long dialogue stuff, and then you have scrolling text and stuff like that, and we can implement that later as well. I think in Zelda, basically what it does is it displays the 3 lines of text, and then once you press space, it advances the text to the next page, basically. And yeah, we can do that later as well. It would be pretty easy, but I think this is not, for now, we can just leave it at that. And we just implement functionality once we need it. And since we only have small text phrases right now, we don't need that yet. Yeah, okay, so let me hide this again. And I wanted to pass the character here, but right now the character basically has a movement model, keyboard control, all the different stuff. I think it's way easier if we create a new component that is just character, and it doesn't do anything. It just maybe has references to all the different models and stuff. So it's so for easy access. I think that would be the best method to do. So let's create a new component, call it character. Go to the code here. And then in character, we are setting up references to all the different models. So we have the character movement model, and we have the character interaction model. I think we only need the models for now. Or do we? I mean, we could use the view as well. Yeah, let's put the view in. Character, movement, the view. Okay. So we have references to we can set up different references here. And in our character, we add this component. Character, and right click, move up, right click, move up. Just have that at the top. And then set up the movement model, the movement view, and the interaction model. So now when we can change the interact on interact method to have character references as well, and we need to change all the override methods as well, because they need to have the same structure. And then in our interaction code, we now have to pass on the character reference here, and we can basically just have set this up at the beginning here. Get component character. So in order for this, there's a helper method in Unity, so that you can force that this whenever this interaction model has is applied to a game object, a character has to be there as well. You can say at the very top here, just go to and type require component. This is an attribute, and then type of, you basically want the character type. And this way, whenever you add an interaction model to a game object, Unity checks if there's a character component on there. If not, it adds the component. And if you want to remove the character, I basically show you. And we do the same thing for... Yeah, well, for now, let's leave it at that. And so let me create an empty game object here. And we want to create add a character interaction model. And hasn't it compiled yet? Oh, there was an error. Oh yeah. Oh, it can't compile because of an error yet. We have to pass on this reference. The character component, we have to pass it on here. And then now it can recompile. Remove this again. And once this is compiled, so now that we set up the require component at the top, whenever I add an interaction model, you see a character component is created for you, because we have this, because the interaction model requires a character component. So this way you can make sure that you don't make mistakes later on. And if you try to remove this, Unity says you cannot remove it because the character interaction model depends on it. So this is just a neat way to make sure that, that you don't mess up later. Okay, so we now pass on the character here, basically, that is interacting with anything. And let's go back to the sign. And since we now have the character, we can say, we can access its movement and set frozen to true. True. And when we hide it again, we set frozen to false. And I think I have to do one more thing in frozen. If the character is frozen, we basically have to make sure that we cannot set a new direction as well. Otherwise we're frozen in place, but we could still look in all 4 directions. So if the character is frozen, then we don't want to be able to set a direction. And let's see, I think, yeah, this should be it. Okay, so now we froze the character in place when we show our dialogue, and we unfreeze him again when we hide the dialogue. Let's press play and see if that works as expected. So we can walk around still, everything is fine, go to the sign, and now I press WASD and we cannot walk. So let's press space again, the dialogue gets hidden and we can walk again. Nice. The question is, won't monsters still attack you though? That's right, we haven't paused the game or anything. I guess you're right, I think in Zelda the game is paused when the dialogue is shown. Yeah, you're right. But let's leave it at that for now. I mean, later on there are different methods we could use. We could freeze the game, but then we can basically. Yeah, you're right. So let's not set the okay. So well, I mean, we need the frozen later, I'm sure. But what we can also do is we could simply set the time scale to 0, which means the time is halted basically, and this might work as well. And this way, the whole world would be frozen. So other characters as well would be frozen. But yeah, so this happens. So we still need to freeze him. We can do both basically. We set the time scale to 0, but we can still interact with it. So let's do both basically, and then this should work. So our character. Movement set frozen to true, so this way we cannot turn, and then set frozen to false. So this way monsters and stuff like that won't move as well, which is how Zelda works, I guess. Okay. So now we can interact with our sign, we can interact with the chest. I mean, we can open the chest, but there is nothing in there yet. So, very good. We can interact with this. And there's one more interactable, which is the Master Sword. We want to be able to pull out the sword. And then there's a sign here as well. This is actually pretty cool, because now I can show you that that this is good. It's good that we created the sign this way, because we can reuse the component. So let's go over to the Master Sword here, and we want to have stuff written on these plates as well, so we can read them. So I have the sword drawing here and the visuals, but we can just create empty game objects in here in our sword shrine, and had the sword text. Put this here, give it a box 2D collider, box collider 2D, and set the collider up so it's actually just here. So the character will not collide with this, because our shrine itself has a collider that is slightly bigger. Oh, let me fix this. This doesn't look very nice. This is better. But since we're using an overlap sphere to detect all colliders in our surroundings, this will still work. I mean, we can, let's make this just a little bit bigger so we make sure that it works. And now we can simply put a sign interactable on here. And Jessie actually told me what this means. She wrote this in Hylian. I think it was wow, wow, sword much sharp or something like this. I have to ask her again. And so now we created a sign here. And then we can also do the same thing. We can create a new one and put this down here. And these are basically invisible colliders, but we can set them up so so all the signs have can be read here. So what do we want? What do we want this left and right plate to say? I'll leave that up to the chat, and then we'll just leave it in. So if you have any ideas what these two signs should say, please yeah, just write in the chat what you want. And while you think of something, let's call this entrance sign 1 and entrance sign 2. And we also want to set up an interactable for the sword. So duplicate this once more, put this up here, and edit this a little bit. Don't take the sword and take the sword. That's funny. That's a good idea, yeah. So, wait, where did I have the sword in stone? Yeah, exactly. This, I have this. Visuals. And we need a new interactable for the sword as well. So let's remove the sign here. Yeah, okay. Don't take the sword and take the sword. I like that. It's funny. So, don't take the sword, and on the second one, take the sword. Awesome. So we set up 3 different signs now. Let's press play and see if that worked as expected. Don't take the sword. Take the sword. Wow, sword, much sharp. Perfect. And if you think about it, the sword is actually acting similar. We can basically use our interactable chest for this, because it's basically a chest as well. But since we have the open chest sprite, we can set this up. We can use a different one here, and we simply let's create a new one that is simply empty. Or we could no, I don't like that a lot. We could make a new boolean here. So boolean hide renderer when opened. So, and then if this is true, if hide renderer and open it is true, we could hide this, and let's store a reference to the renderer as well. renderer So if hide renderer when opened is set to true, then we just want to disable this, and in here we want to check oh, this has to be a sprite renderer so that we can have the sprite component here. That should work actually. I think it would work before as well, since this is none, the renderer would simply be set to none. Let's see if that's the case. Let's just press play. I haven't clicked the disable renderer now. And if I get this, yeah, the sort gets removed. So we actually don't need the hide renderer because the open chest sprite is simply empty. So when we interact with it, the sprites get set to null here, and so nothing is rendering anymore. So our sort is actually just a chest, which is cool. So you can reuse your components as however you want. Cool. So we have two chests, and we have multiple different signs here, and then we set up our interactable system in a way that we can later on, if we have, for example, a switch, we can create a new switch, interactable switch component and stuff like that, or yeah, whatever we can think of, basically, which is pretty cool. Let's see. I think you have to freeze the character first and then set the timescale to 0, because otherwise the animation will be midway. We can check, yeah, maybe. But we don't have an animation there. Let's see. Well, we do. I think this is... Okay. Yeah, you're right. Could basically end up in like flying. That's true. But if we set it to frozen, we need to make sure that the view knows of it. So let's see. Let's go to the sign first. Set frozen to true. And then also the character movement view. What do we have to do here for it to work? Basically we want to set... Oh, we have is moving here. That's fine. But we have to make sure that the update is being called before the timescale is set. We need to make sure that this update method is being called before the timescale is set to 0. Otherwise, this will not trigger at all. First of all, we can go to is moving. So turn if why is Visual Studio not working right now? There you go. Just a little slow. So if it can only be moving if frozen is false. This is not very readable. I don't like if statements if they result to false, because it's counterintuitive to read it like this. So in this case, I actually just make it like this. If the character is frozen, always return false. This is much more readable. Yeah, because as I said before, I value readability a lot, actually. Okay, so now we have to make sure that the movement view is updating. Can I just call update? I mean, I can just call update, yeah. We could make this update method public and then just call update. I think that this is the quickest solution. So make sure we set it to frozen and then update the view once more so that the animation is updated as well. And this should deal with that problem. Or not. Why not? So we set it to frozen and then we call update. Oh, because since we're setting timescale to 0, the animation is not updating anymore. The animation is actually updated after all the update methods are called. So between late update and update, the animation gets updated. So we in order for this to work, we don't have to call update. What we can do is we just wait a frame before we set the timescale to 0. And wait a frame we can do with something called a coroutine. So a coroutine is very handy in Unity. Basically the onInteract method is handled line by line. So it's when we call it, basically it goes from the top to the bottom here, and everything is handled sequentially, basically. And coroutines can break out of that. Coroutines basically can say, make sure this code, this type of code is also being processed in parallel. And what that allows us to do is, so basically you have a new piece of code that is called as a coroutine, which is a separate thing. But you can what you can do now is you can pause the execution of the coroutine for a frame or for 2 seconds and stuff like that, which you couldn't do here, because if you would pause the code, then you basically would pause the whole game, the execution of the whole game. Yeah, so the way we can wait one frame is basically just we yield. And normally you would say yield return, for example, and then you can create a new wait 4 seconds and say, okay, let's wait 1 second and stuff like that. So you basically said yield, and then you return an object how long you would like to yield or to what event you would like to yield. And we simply want to wait 1 frame, so yield return null basically says we yield, but we don't want to yield after that, and we don't set a time how long we yield. Basically it's just we yield, and the next time the coroutine is executed again 1 frame later, basically it just continues on. So yield return null means we wait 1 frame. And then we want to set the timescale to 0. And you cannot just call the coroutine. You basically have to tell Unity to start the new coroutine. So start coroutine, and then have your function here. And this function can have parameters as well. So whatever. And then you can have. So you can have as many parameters as a normal function, but you call it like this: start coroutine, to so that Unity sets up this new system, the coroutine that you can pause separately. And you can have as many coroutines as you like, and they are always executed in parallel. And since they are executed in parallel, you can pause one and the others will still execute, stuff like that. This is why you can pause a coroutine, but you cannot pause your main flow, basically, because that would pause the whole game. I removed too much here. I only want to remove the parameter again. Alright, so let's see if this fixed our problem. Let's press play here. Has to compile. Then if we walk, yeah, seems to work. Okay, so yeah, this fixed our problem. So we needed to wait one frame before we freeze the time, so that the animator can update and make sure that the character is standing still, and then we just, yeah, and then we freeze the game. And since this is, we're basically just waiting one frame, I mean, the game will run at 60 frames a second or even more, stuff like that, so it won't be noticeable that that the time will be frozen just a little bit later. So there's no problem there. And it was an easy fix, which is good. Alright. So now we have the sign interactables and we have the chest interactables. Now we obviously want to have something in the chest. And we have 10 to 7 right now, so let's just start this and plot this out a little bit. But yeah, I usually go only 2 hours till 8, so there we have 10 more minutes. So we won't be able to finish that code yet to get items, but we can start it. So since Zelda, you will later on have many different items. You can have a bow, an arrow, you can have bombs, and you have the sword and shield and stuff like that. We basically want to code a full inventory system. Just a system that stores all the different items that we have. And then we can basically, it's basically just a list that has all the items that we have. And then we can call that component, ask, do we have the sword? If yes, make the sword animation when the user presses the attack button and stuff like that. So we need a couple different things. First of all, we need our inventory. This is a new script, and it's basically, since this is a model as well, since this stores data and stuff like that. It's not a view, it's not visible. Later on we also have an inventory view. When we press start in Zelda, you can press start, and then basically you get your inventory and can select the different weapons, but we're not doing that now. And it's also not a control, because it's not, we are not interacting with it. It basically just stores the data. So we have a character inventory model. Are you going to hard code the item database or read a file? I'm not going to hard. Well, I'm not sure yet. I think for now, for today, we're going to hard code our first couple of items, and then later on, when we add all the different weapons, we actually create a more robust thing. So we have an inventory model. And basically what this does, it stores the objects that we have, and we can also use this to store like rupees and keys later, which we could have multiples of. So let's use a container object that is called dictionary for this. Dictionaries are very cool for stuff like databases, and I'll show you why in a second. I need system collections generic. So a dictionary is very similar to a list, but it expects 2 parameters. It expects a key and a value, and basically you can then access the value through the key, and the key can be of any type. So we can have, basically you can have a string dictionary and an int value, for example. I'll change it later, but this works. And then, so this is our call this items, and then we could basically say add sort, and then a value of 1. And this way we would basically add a sort type to this container with a value of 1. And if we have like key, for example, or it's like add small key with a value of, oh, I have to zoom in, small key with a value of 5, so stuff like that. So basically it's a list of types, and each type has another value attached to it. In our case, an integer works very well for the items, but you could basically both of these, the key and the value, can be of any data type you want. And we are going to use that. So we could just use a string here, but I actually don't like that, because then you always have to remember the exact spelling of all the items, and you could introduce bugs later by saying add small key. If you have a typo in there and you add a big key, a small key with just one L, for example. Yeah, it's easy to write typos with this system. So what I did in previous games as well is I create an enum for this, an item type enum. So let's create a new script called item type. And this is simply, actually we don't need anything of that. Let's remove all this code here. And this is simply an enum item type. And then we could, for example, we just put sword and shield in here. We can put all the different types of items in here. And now what we can do is, we can say this is not a string, but this is an item type. As I say, you can put any data type in here. And then you type item type dot sort, for example, 1. And this way you can basically, you have code completion for your data. So whenever you type item type and dot, you have all the values that that you can have here, and you will never have the issue that you will have a typo in there and stuff like that. So I like this a lot, and I use this in my game Farm for Your Life as well, this way here. Another thing is an enum assigns a value to the keywords. If you don't set that value yourself, it's basically it's just counting up. Basically, this will be the value 0, this will be the value 1, and so on and so on. But you can assign values yourself. So you could basically say sword is 0, that's fine, but I want the shield to be 10, or let's say 100. And I'm going to do that for all the different items. So for example, I can say like the small key is going to be 200, and then later if I add the big key in here, I set this to 201. And the reason I do this is I can group stuff together. And for example, if I don't have this, if I don't have the numbers here, it will just count up, right? So it's 0, 1, 2, 3. And Unity actually stores those values. It doesn't store the sort part, how you named it. It stores the value. In this case, the sort value is 0, and the shield value is 1. So let's say you set your character has a shield. So Unity stores the item type with the ID 1, and you have that. But now that you create a new sword, let's say master sword, and now all of a sudden the shield has the value 2 and the master sword has the value 1. And if you stored the value somewhere, or for example if you used this in the chest and said this chest has a shield in it, now all of a sudden, because you added a new item, that all the chests that have had a shield in it before now have a master sword in it. So that's why I'm going to say the sword is 0, the shield is 100, the small key is 200, and big key 201. This is fine basically, and I will categorize them so I can add multiple different sorts here if I want later, and then I have all the other items below that as well. But I can add a new sword here, so I can group them together. So can I put master sword here and laser sword and broadsword or something like that, and all the other values won't change because of that. So this is just basically a safety mechanism. Okay. And there's a question. The int shows the amount of the specific item. You mean in the inventory here, right? So we have an int here. Yes, it shows the amount. So this way we can use it for keys as well, because you can have multiple different keys. We can use the same system for the rupees, which you have can have many of. So yeah, that's what we're going to do. And so in the inventory model, we need basically a method that says add item type, and I have two different of these, one with the value and one without. This way I can basically just write, let's say, int amount, and this one calls the other one item type with an amount of 1. So basically, if I call add item without a value, it always uses the value 1. It's just a shortcut basically for later. And then we add this to the items here. So I told you there is this add before, and add basically adds a new entry into the dictionary with this key and value. But we also need to check if we already have that, and then just add the amount to it. So what we can do is, if items contains key, we check basically if we already have it. If it contains key, no, let's do it the other way. If it doesn't contain a key, what's easier? No, let's do true here. So if we have the item, so let's say we put a sort here. In the start function, we can do add item type sort, and we do this 2 times. Basically, we need to we want to increase the value the second time. So if we have the key already, then we can access this key item type and just add the amount to it. And if we don't have the type in here, what? If this is the first time that we store an item of a certain type in here, then we basically add a new value with the amount in here. Right? And then, so we can put add items in here. Well, add item is enough for now. We don't need to write any code that we don't need yet. But later you can imagine that we can have functions in here to remove items and get a value how many items we have of a certain type. So the character inventory model, let's add this to our character as well, so we can access it quickly. Public inventory. And once we have that, we can do stuff like, so let's go back to the chest again, and we can add another variable here, a variable of item type, and you'll see in a second why the another benefit of using an enum here is. So item in chest, and we also want to have an amount in here. So basically, when we open the chest, we want to access the inventory of the character, inventory, and we want to add the item that we have in this chest, and we want to add the amount. Maybe the chest has like 500 rupees or something like this. So yeah, and now we set this to these two public variables. So if we go back to the chest, and once this compiles, there are some errors here. Where did I go wrong? Oh, this has to be a public enum. Public enum, so I can access it from anywhere. And now you can see in the chest here, once it's done compiling, that we have the new values here. And since we're using an enum, Unity actually gives us a nice drop-down list here of all the items that are possible. So again, we don't have to type it in, we cannot make any typos and stuff like that. So this chest should have a shield and the amount of 1. And then for the sword, actually, we can do the same. This chest has an item sword and the amount 1 as well. And here's one thing, I forgot one thing. I want to add item type none to here, so that there should be an item called none, because we're going to use that later. So let's do none to 0 and start the sword at 100. Actually, let's move them all up, and you can see what the problem is, because now before the shield had the value 100 and now the sword has the value 100. So if we go back and this compiles, the sword had the value of 0, and now once it's ready done compiling, you see the item type 0 is now none, and in the chest we actually now have the sword because the value 100 was stored. So let's put the shield again here, and we put the sword here. Yeah, and basically let's debug this so that we know what happens, and then we break and we can continue working on this next week. So let's go in the inventory. We basically say debug log item type. Oh no, let's start with amount plus space item type added. So whenever something gets added, Unity tells us. Remove this maximize, and let's see. Press play if everything worked. And so let's move over to the chest, interact with it, and then we have a null. Oh yeah, I know what we haven't set up yet. This from our character, we haven't set up the inventory yet. We haven't added it actually at all. It cannot work if we haven't added the inventory. Let's move up, and we have to set the inventory in here. Press play again. How often do you stream? I stream every Saturday at the same time. So in European time, this is at 6 p.m. If you're on the East Coast, this is at noon, and if you're on the West Coast in America, this is 9 a.m. and it's always 2 hours roughly. Okay, let's interact with the chest now, and you see found interacted with chest, and oh wait, we have to remove this. This is confusing, the two debugs add items that we had before. And I also want to remove this found interactable. We don't need that anymore as well. Okay. Another question was, are these broadcasts saved in your profile? Yes, I save it. Well, they're saved for 2 weeks on Twitch, and I also have a YouTube channel. If you go to letscodegames.com, there's a link to the YouTube channel, and I'll link it in the chat in a second as well, and I upload them there. I actually haven't uploaded the stream from last week yet because I was sick this week, so I'm behind on that, but tomorrow I will upload this stream and the stream from last week, and then we're back on. So this is actually week 4, so we haven't missed much yet. Okay, so let's go to the chest, press space here, and then 1 shield added. Whoa, my camera fell down. It's not good. Makeshift. A stand for my camera here. It's just a stick basically, and I take it to the screen. Okay, so and let's go to the sword as well. Interact with that. 1 sword added. There you go. So basically this is the beginnings of our inventory. And yeah, and then we need ways to access that, so we can find out if we have an item in there, how many items we have in there, stuff like that. But yeah, so we have a working chest now, and we have a working sword. And actually, I mean, I'm not doing this today, but this is very underwhelming now. That's just something happens. So if you remember in Zelda, you always have this nice animation, and Link shows what you got and stuff like that. And we have animations, we have frames for that. So next time, let's see if I can see them quickly. Preview this. There you go. So we have very nice frames here from Link picking up the sword here and picking up the shield, so we can use those. So we're going to do that next week, basically when you go to the chest, that he shows off what you got, the item that you got. Also, since we now got a sword and shield, well, the sword the sword will be visible on the character. So next time we're going to figure out how we do that, how we can attach an item to the character so that's visible. As you saw here in the animations, we also have very awesome attack animations. So maybe we can even start attacking stuff next week. Yeah, I think this is a good stopping point. So yeah, as I said before, let me just go through the things here. We can go to letscodegames.com, and you can find my schedule here and also the link to the YouTube channel, and I'll link it in the chat as well. YouTube channel. Welcome to Let's Code Games. I upload my stuff here, all the streams, the past streams, and actually last time, the first stream I split up in 6 different videos, but I didn't like that too much, so I think I'll just upload the whole stream. We'll see. I mean, let me know what you prefer. I would like to get some feedback on that. So I split them up in logical groups basically, but yeah, I think you can just upload just the whole stream, because otherwise there are just too many videos here and people cannot find the right videos. Yeah, and also if you want to get reminded when I go live, it's always the same time on Saturdays, but I have a Twitter account, so you can go to twitter.com/letscodegames, and I will tweet when I go live and remind you a few hours earlier as well. So this is, just follow me on Twitter, and then because I need more followers, I only have 14 there. Oh, that's fine. You can follow me on Twitter or follow me on Twitch, and you will get an email when I go live. I think you know the spiel of that. And that's it for today, actually. I'll just leave you with some nice music that was written specifically for this tutorial for this game. And we will implement that at some point in the future as well. But it's some awesome music to play us out here. And then I hope to see you all next week again. And as always, I will upload all of this to our Git repository, and you can just grab everything we did today. I think it's letscodegames.com/Zelda. Yeah, letscodegames.com/Zelda, and there you find the link to the Git repository. Oh no, I haven't put it up here yet. I need to update the website. Right, okay, let me paste the link in the chat. So this is the link to the Git repository, where you can get all the code, and I will upload today's code in a minute. And yeah, you get all the assets for free and all the code for free. So poke through it, see how we did stuff, and hopefully you learn something. And I'll see you all next week. Goodbye.